Let's expand our knowledge on solving quadratic equations and solve some quadratic inequalities. Now, if you recall back to integrated algebra, inequalities are solved very similarly to equations. So that's exactly what we're going to do with quadratic equations. We're going to treat them like an equal sign. So if we had x squared minus 3x is greater than 10, what I'm going to do is pretend this is an equal sign. But I'm still going to get it into standard form. Again, descending order and equal to 0. So I'm going to subtract 10 from both sides. Okay, now that it's in descending order and equal to 0, I'm going to just pretend this is an equal sign. So I'm looking for factors of negative 10 that add to negative 3. And those factors are negative 5 and positive 2. Now this isn't really an equation. I'm going to have to remember to go back to a greater than sign in the future. So let's solve. X equals 5. X equals negative 2. There was an intermediate step here of setting each factor equal to 0 and adding 5 to both sides and subtracting 2. So now these aren't my solutions. This is simply breaking up my number line to determine my solution. So what you have to do is set up a number line and list them in order, negative 2, positive 5. Now since we had a greater than sign, that implies that we do not want to include these two solutions. So we're going to use open circles. If that were greater than or equal to, that would imply that we would be including that, so I would close the circle. Now, our solutions will be either one of the two following. Shade the inside or shade the outside. One or the other. It'll never be one direction. It's either inside or outside. So what we're going to do is test our number line. So for x equals 0. Now 0 is here. So I'm testing the middle. If I get a true statement by plugging in x equals 0, I'm going to shade the middle. If I get a false statement for x equals 0, then I'm going to shade the outside. I'm using 0 because it's an easy number to work with. You can use any number you want, just don't use the numbers that you got in return. Don't use 5 and negative 2 in this case. If you can use 0, use it because it's the easiest number to plug in. So what I'm going to do is plug in x equals 0 to our original inequality. 0 squared minus 3 times 0 is greater than 10. 0 squared is 0. Oops, that's a 10. So 0 is greater than 10. That's false. So now I tested here. I got a false statement, so I do not want to shade the middle. I'm going to shade the outside now. So these are my solutions, and this number line helps you write it in solution notation. My solution is going to be x is less than negative 2, not including, or x is greater than 5, not including. Let's do one more example. Let's say we had x times x minus 8 is less than or equal to 33. First things first, I'm going to use closed circles now because now it's less than or equal to. So let's distribute the x, giving us x squared minus 8x, and subtract 33 from both sides. I'll do that in 2 different steps. Rewriting the same equation, inequality rather, minus 33 is less than or equal to 0. So now I'm looking for factors of 33 that are 8 apart. Those factors turn out to be 11 and 3. X minus 11, x plus 3, and equals, I'm going to put a question mark on top of that. I don't know if it is equal to it. I'm just trying to find my two numbers. X minus 11 equals 0. x plus 3 equals 0. So x equals 11, and x equals negative 3. So now, let's set up our number line. Negative 3 and 11. Now we're going to use closed circles because it's less than or equal to, so it may be these two numbers. We're going to shade either the inside or the outside. One or the other. So let's test the middle. For x equals 0, we're going to plug it into the original equation. 0 times 0 minus 8 is less than or equal to 33. 0 times negative 8 is less than or equal to negative 33. 0 is less than or equal to negative 33. Yes, it is. Which means the area that we tested is true. So that's what we'll shade. So we're shading the middle. Now the last inequality was easy to write. When you shade in the middle, this is saying x is between these two numbers, including these two numbers. So the way you list it in inequality notation is called a compound inequality. We're going to say x is between, and your arrows always point to the left, including negative 3 and 11. This is saying x is between these two numbers, including these two numbers. And your arrows always point to the left in a compound inequality, and that's only when you shade in the middle. So this is our solution.